Happy Friday. Today is going to feel a little bit like an English lesson. It's going to be a little bit different. I'm teaching it out of order, but I feel like this one, since I'm not there, might be a little bit easier to learn than the one I was supposed to teach. So I kind of rearranged a few things on the calendar. So if you go into Canvas and go to your calendar, I want you to pull up the lesson for today. I already have it pulled up here, and we'll talk about it. And then also go ahead and pull up the assignment. So you're actually going to be typing on a piece of paper today. Well, typing on a Google document. So I want you to make a copy. And then you're going to submit your document to me when you're done. So go ahead and get that pulled up and the lesson pulled up. So today is Friday, October 23rd. Virtual Monday will be on November 2nd. Your test over Chapter 2, this is the very beginning of Chapter 2. Your test will be on November 17th, and then we have Thanksgiving break the 23rd to the 27th. So I've got everything in the calendar there. All right. So today is going to feel like an English lesson, like I said. Today we're going to talk about conditional statements. Conditional statements. You're going to be like, but we're in math. Why are we doing all this writing? Well, all of this writing is going to prepare us for writing proofs later. So we're going to be writing proofs eventually in geometry. So these statements will just help with that. So hopefully today will be an easy day. Okay. So conditional statements. A conditional statement is just another name for an if-then statement. The if part is called the hypothesis, and the then part is called the conclusion. You've probably heard about hypotheses and conclusions in science class. So here's your first example. If you study hard, then you will get an A. So the hypothesis is the if part, you study hard. The conclusion is the then part, you will get an A. So in geometry, a lot of times we represent statements with P's and Q's. So the symbolic form would be P arrow Q. That just means if P, then Q. P can be anything and Q can be anything. So for your first example, it says, if it is Saturday, then there is no school. Your hypothesis is the if part, if it's Saturday. Your conclusion is the then part, then there is no school. Here's another example. If x minus 8 equals 32, then x equals 40. The hypothesis is the if part, if x minus 8 equals 32. The conclusion is the then part, then x equals 40. One more example. If a polygon has 4 right angles, then the polygon is a rectangle. Hypothesis is the if part, if a polygon has 4 right angles. Conclusion is the then part, then the polygon is a rectangle. So if you look at your assignment on number 1, 2, and 3, you're just going to identify the hypothesis, which is the if part, and the conclusion, which is the then part. So numbers 1, 2, and 3 shouldn't be so bad. All right, writing a counter example. So a counterexample is something that makes a conditional statement false. So for example, if x squared equals 25, then x equals 5. So you can never change the if part when you're writing a counterexample. If x squared equals 25 has to stay the same. I wouldn't change it to if x squared is 36 or something. Keep the if part the same. It's the conclusion that you give a counterexample for. So does x always have to be 5 if x squared is 25? Well, you might think so. But what about negative 5? Negative 5 times negative 5 is also 25. So that would be a counter example. So let's try a couple. If it is a weekend, then it's Saturday. So the if it is a weekend has to stay the same. You can't change that. It's got to stay the weekend. But does it have to be Saturday? Well, my counter example could be, it could be Sunday. Here's another example. If you live in a country that borders the United States, then you live in Canada. Well, my counter example could be, I could live in Mexico, right? So I'm going to try to keep my picture maybe up here. Ah, look, I can make it smaller. Okay, so let's go back to the worksheet. So we're going to write a counter example on numbers 4, 5, and 6. So number 4 says, if it is 12 noon, so that has to stay the same. You can't change that. If it's 12 noon, then the sun is shining. Well, is the sun always shining at 12 noon? What could be a counter example? It could be raining, right? Number 5 says, if a car is full of gas, then it will start. Will it always start if it's full of gas? So you got to keep that part the same. It's full of gas. But what could be a counter example that could make it not start? Like maybe a bad engine or something. Number 6 says, if a number is divisible by 3, then it's an odd number. Well, does it have to be an odd number if it's divisible by 3? What about 6? What about 18? Anyway, those are examples of counterexamples. All right, moving along. I don't think I have. So on 7 through 10, you're actually just going to rewrite that statement in if-then form. So like, for example, number 7 says, get a free water bottle with a 1-year membership to Genesis Gym. That's where I teach. So you could say something like, if you get a membership to Genesis, then you get a free water bottle. Number 8 says, everyone at the party receives a gift. So you could say something like, if you go to the party, then you get a gift. Number 9 and 10 might be a little bit harder, so let me help you with those. Number 9 says, the intersection of 2 planes is a line. So you might say something like, if 2 planes intersect, then their intersection is a line. Number 10, collinear points lie on the same line. So you could say something like, if points are collinear, then they lie on the same line. Okay, so hopefully that's helping so far. Let's move on to converse. You like my Converse shoes? So if you have an if-then statement, like if it is raining, then it is cloudy, the converse takes the hypothesis and the conclusion and switches them. It just flips them. So instead of saying, if it is raining, then it's cloudy, I would start with the conclusion part. If it's cloudy, then it's raining. So that is the converse. Let's look at a couple of examples. And then we're going to talk about the truth value. So this says, if you live in San Diego, then you live in California. That's a true statement. If you live in San Diego, you live in California. The converse takes the conclusion and the hypothesis and flips them. So converse is, if you live in California, then you live in San Diego. Well, is that necessarily true? Not necessarily. If you live in California, there's lots of cities in California. So that's not true, but you're still going to write it. So you still write the statement anyway, even though it's not true. The next example says, if 2 angles are complementary, then their sum is 90 degrees. Now the thing about this one is the subject of the statement has to stay with the if part. So if 2 angles are complementary, the subject of our statement is the 2 angles. So that's what we're talking about. So if 2 angles right here has to stay the same. But I'm just going to flip the conclusion and the hypothesis. So if 2 angles have a sum of 90, then they are complementary. So do you see how I flipped the conclusion and the hypothesis? Let's talk about negation. So the negation of a statement is just the negative of a statement or the opposite of the statement. So for example, if my statement says it is raining, my negation would be it's not raining. If my statement says the sun is not shining, the negation would be the sun is shining. The symbolic form for that, so is the little squiggly. So angle 3 measures 90. That's my symbol, my P, my if part. My negation would be an angle does not measure 90, and it's the little squiggly P. Angle 3 is not acute. Angle 3 is acute. So the little squiggly is just the negation. Okay, which brings me to the inverse. So we've talked about just a regular conditional statement, an if-then statement. The converse takes the hypothesis and the conclusion and it flips them. The inverse goes back to the original statement and you add the words not, or you negate. You negate the hypothesis, you negate the conclusion. So my statement says, if it is raining, then it's cloudy. The inverse takes the original statement and negates both the hypothesis and the conclusion. If it's not raining, then it's not cloudy. Then there's the contrapositive. So converse and contrapositive both start with CON. So the contrapositive takes the converse and negates it. So you flip it and you add the nots. So my original statement says if it's raining, then it's cloudy. I've got to flip it and add the nots. If it's not cloudy, then it's not raining. So here's an example. If you own a cat, then you have a pet. So the converse just is the flip only. No negating, just the flip only. If you have a pet, then you own a cat. Now, is that true? Just because you own a pet, do you have to have a cat? Not necessarily. I have cats, but you don't have to. The inverse goes to the original statement and adds the nots. If you do not own a cat, then you do not have a pet. That's also a false statement because just because you don't have a cat doesn't mean you don't have a pet. And then the contrapositive takes the original statement, it flips it, and adds the nots. If you do not have a pet, then you do not own a cat. The contrapositive is the only statement that's always true if the original statement is true. Contrapositive is always true if the original statement is true. That is number 20. If a conditional statement is true, then the blank is always true. It's the contrapositive is always true. All right, so we talked about just a conditional statement, if P then Q. The converse just takes the P and Q and flips them. Converse is the flip. The inverse goes to the original statement and adds the nots in there. If not P, then not Q. And then the contrapositive takes the converse. So you take the converse and add the nots. If not Q, then P. All right, so my statement says if the car starts, then the battery is charged. Whoops. Converse, if the battery is charged, then the car will start. Inverse, if the car will not start, the battery is not charged. And then contrapositive, if the battery is not charged, then the car will not start. And then I just have this little Thanksgiving funny on here. All right, so the turkeys are saying moo because they don't want their head to get chopped off anyway, you know, turkey. Okay, so let's look at a couple here. So number 11 says, if you live in Chicago, then you live in Illinois. So I'm going to change the color. The converse just takes your statement and flips it. If you live in Illinois, then you live in Chicago. And yeah, I know that's not true, but you're still going to write it anyway. Inverse goes back to the original statement and adds the nots. If you don't live in Chicago, then you don't live in Illinois. And then the contrapositive goes with the converse. Notice CON and CON. Contrapositive negates the converse. If you don't live in Illinois, then you don't live in Chicago. Now, what about if there's already the word not in it? Like number 12. Let's look at 12 together. If a bird is an ostrich, then it cannot fly. So the converse just takes the original statement and flips it. And what's the subject of my statement? What are we talking about? We're talking about a bird, so the bird has to stay the same. So I'm going to say, if a bird cannot fly, then it's an ostrich. So all I did was take this statement and I just flipped it. If a bird cannot fly, then it's an ostrich. Inverse goes to the original statement and negates it. So I would say, if a bird is not an ostrich, then it can fly, because I'm just negating that statement. And then contrapositive goes with the converse and negates it. So I would say, if a bird can fly, then it's not an ostrich. So I hope that helps. If you have questions, just let me know. Thank you.